What up, everyone? This is LeetCode 409, longest palindrome. So we're given a string s, and it can have uppercase or lowercase letters, and we have to return the longest palindrome that can be built with those letters. So for this particular input string, this is the longest palindrome that can be built. And the longest palindrome reads the same forward as it does backwards, right? So, and it also can be case sensitive, right? Capital A, lowercase a is not a palindrome. So we're given a string and we have to find what is the longest palindrome that we can form from this. So how are we going to approach this? Let's think about the properties of a palindrome, right? So if you have an even number of an even number of frequency for a particular letter, that entire letter can be added to the count here, right? For example, we have 4 C's, which is an even number, and then 2 D's, that's also an even number. We can just add all of that to the count. So 1, 2, 3, 4, 5, 6. Okay. Now let's think about cases of the cases relating to the odd frequencies of a particular letter, right? We have A, which is frequency of 1, B is a frequency of 1. So if we have an odd frequency, right, we can include it. And by the way, this wouldn't be a palindrome. We need to put the D over here. Now, okay. Sorry, I put the 2 D's at the end instead of putting 1 D here to make it a palindrome. So if we have so A is equal to 1, B is equal to 1 in terms of their frequencies, we can use one of those letters and plug it in the middle, right? We could do that, and we'll have a palindrome still, right? Now let's think about B. Can we use B somewhere in here? No, we can't, because it would not be a palindrome, right? But what we can do, and what we need to think about regarding, an odd number frequency for a particular letter is that we can use it. We just can't use all of it. Like, for example, let's say this input string here had 3 Z's, right? How would we put 3 Z's? Well, we can't use all 3 Z's, right? But what we can do is we can use 2 of those Z's to add to our count, right? And so now our palindrome will be even longer. Obviously, we don't have Z's here, but I'm just using it as an example, right? So likewise, let's say, let me do another input string as an example. Now let's say I had Z's here, okay? What could we do? Okay, let's add all 3 Z's to the middle. Can we add A somewhere and make it a palindrome? No. Can we add B somewhere and make it a palindrome? No. We can use the C's though, right? And we can use the D's and make it a palindrome. Now let's look at the original example here. And let's say we had, like, I gave you the example of 3 Z's. And what was the output? This was the output, right? Now, notice, even though these palindromes are different, right? Notice the counts are the same, right? Because we're handling the cases of odd frequencies the same, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So the way we want to handle this, because it's really going to depend, right? Are we encountering an odd frequency that's greater than 1? The first odd frequency that we encounter, is it going to be a number greater than 1, or is it going to be a number that is 1, right? It doesn't really matter. We just have to make sure that the second time around that we handle an odd frequency, count, we need to make sure that we don't add the entire thing to our count, right? Like, for example, right here, let's say we add 3 R's. We don't want to add all 3 R's to our output. We only want to add 2, right, to keep it a palindrome. Likewise here, if we had 3 R's, we don't want to add, this is going to be this is not going to be the first time we encounter odd frequency an odd frequency, so we don't want to add the entire thing to our palindrome. Okay, so you need to think about kind of how you would handle the cases of odd frequency, right? So let's start out by making a counter, right? This is just going to be a hash map that basically has the letters as the keys and then their actual counts as the value, right? So A is going to be equal to 1, B is going to be equal to 1, C is going to be equal to 4, and D is going to be equal to 2. Okay, that's all this is. Now, we're also going to have a character or a Boolean variable a Boolean variable called single found character. And that's going to be set to false, okay? Now let's iterate through this count here. So we're going to say 4 counts in c.values, okay? And this count is going to be a number, right? It's going to be the actual value of like the hash map. So when we are, so initially it's going to be 1, right? Because it's going to look at the A. Then it's going to look at the B, that's also 1. So this count is actually a number, right? So let's say if single found character, that's going to be the case where it's true, and this is going to be the case where it's false. Now let's handle the case where it's false, because that's obviously the very first. We're always going to go in the else statement first. So in this case, we want to add the entire thing. We want to add the entire count to output, okay? Now, if it's not an even number, for the frequency, we want to set this to true, okay? Because if count is initially an even number frequency, like if let's say these 3 C's were at the very start, we just want to add all the C's into our count, or we want to count all of those, right? This output is going to be here, right? We want to add all these 3 C's to this output counter because well, they're not an odd frequency, so we don't need it. We don't care about this Boolean variable yet. Now, when we encounter the A the first time, this is where we're going to flip this to true. Or likewise, let's say we had 3 Z's at the start. This is where we add all those 3 Z's to our output, and we set this to true, right? But in this case, the first odd frequency count is A, which is 1. So we add 1 to the output, right? And, you know, just to make this easier, I'm going to kind of keep track of our palindrome so far as I work through this example. So right now, our output is 1 right now, right? We add A and we set this to true. Now we go to B. B is equal to 1. So we're always going to enter this if statement now because this is true. Okay. So if we encountered an odd frequency already, we can use another odd frequency, right? But what's the condition? Well, the condition is that we can use the odd frequency of another character only if it's greater than 1, right? Like, for example, if we had 3 Z's, we can add 2 Z's, right, to our palindrome. But if we only have 1 Z, we can't use that, right? Because we would mess up our palindrome. It wouldn't be a palindrome. So if we encounter an odd frequency for a particular letter, you know, again, right? First time we encounter an odd frequency is for A. If we encounter an odd frequency again, the count has to be greater than 1, right? In order for us to actually use it in our palindrome. So we're gonna say if count is greater than 1. And by the way, in cases where like C or D, these are always going to be greater than 1, right? Right? Obviously, because even lengths always are going to be at 2 or 4 or 6 or 8 or whatever, right? It's always going to be greater than 1. But odd frequency is where it matters because, well, the odd frequency can either be 1 or it can be greater than 1. So that's why we kind of have to add this if statement. This is just going to handle cases where the odd frequency for a particular letter is obviously greater than 1. Because again, it's the second time we're encountering, the second or more time that we're encountering an odd frequency. So we're gonna say if count is divisible by 2, right? If we have an even number or an even frequency for a particular letter, we just add the entire thing to our output, right? The entire count to our output. Now, else, right? And this would be a case like this, or this, right? Where the odd frequency, it's greater than 1. But it is an odd frequency nonetheless, but it's greater than 1. So what do we do? Well, in that case, we would sorry, I'm thinking about going through the example again. I just put this down here and didn't work with you. So yeah, let me just add this. This is what we would do, right? And this particular first example is not good because we don't have a case where our odd frequency is greater than 1. But let me think. So we have A, right? Then we go to B. Is the count greater than 1? No, so we would never enter these. Then we have this. Count greater than 1, yes. If it's an even frequency, yes, so we add the entire count, so 4. So it would be C, 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 C. And our count now is 5. Okay, now go to D. Then we add D, D. Count is 7. And see, we do have the longest palindrome now. See how it works? That's how the algorithm works. Now, let's say for example, our input string was not this, but this, right? Now, when we if we use this example, when we hit the Z, the counter is going to be 3, right? So count's greater than 1, yes, so we enter. Now, it's not even, it's odd, right? So in order to use these Z's in the palindrome, we don't want to use all of them, right? Because it's an odd number. But we can use all even numbers. So what we would do is we would take the count and subtract 1, and we could add that to our output, right? So 3, we add, what's 3 minus 1? That's 2. So we add 9, right? Why? Because we can use 2 of those Z's. See how it works? Very simple. We can use 2 of those Z's, but 3 of those Z's, we cannot, okay? I think it's pretty simple. So now we can go down here and return the output. Cannot access local variable. Sorry, I didn't create the variable up here. Okay. See, it works. Now, I'm gonna just quickly go over another solution that you can use, which is, I'm gonna call, you can use a set to kind of do kind of the same thing. So we're gonna create a palindrome set, just call it pal set. And we're gonna iterate through the characters in S, right? And we're gonna say, if char not in pal set, we add char to right? Or actually, we'll just do this. Make it a little bit easier to read, okay? So if we don't have a character in the set yet, we add it to the set. Now, what happens if the character is in the set? Well, if the character is in the set, that means it's an odd frequency so far. So what we would do, if our character is in our pal set, right? In our palindrome set, that means we're encountering a character for the second time, which would mean it's an even number, right? So we would say, let me see our output down here. Our output, add that by 2. And since we're encountering it a second time, we have to remove it from our character set, right? So how would this work? We add an A, then we add a B, And so let me actually do this, just so you can kind of know what's happening. So in our set, we have an A, then we have a B, then we have a C. Now we're encountering a C for a second time. So we add 2 to the output and delete the C. Now we add a C, then we encounter the 4th C. So we delete this from the set, and we add 2. Our count is 4 so far. Then we have D, then we counter the second D, and so we delete this from our set, and we add 2. Okay, so right now we have a count of 6. And so down here when we return, what we're gonna do is we're gonna say return output if not set, else output +1, right? So what we're doing here, right? What we're doing here is if there's nothing left in the set, that means we've only encountered even frequencies the entire time, right? But if there's something left in the set, that means we have an odd frequency. So we would actually add 1 to the output because it should give us the right answer, right? Because it'll handle the cases where we have 1A or 1B, right? Now, and just to make it clear, for example, like if we have 3 Z's, right? Like that one example I used previously, right? When we encounter that second Z, we add 2 to the output, right? So all that's left in the set is this, right? There's something left in the set, so we just add 1 to the output, and it'll give us the right answer, right? So yeah, yeah, I didn't come up with this solution, but I saw it somewhere else, and I thought it was actually pretty clever. So I mean, I already ran the code, so it should work. It's just taken forever. LeetCode's kind of seems like the servers are kind of buggy today. But yeah. Anyways, I just like that second solution. I thought it was kind of clever, so I wanted to show it. But yeah, I think I explained this pretty well. I tried using examples as best I could so that you could understand. And, you know, regarding the lowercase and uppercase, that would be reflected in the set and also in the counter, right, in the hash map. So regardless of what solution you use, it would handle the cases of lowercase and uppercase. So yeah, this problem isn't too difficult once you kind of get the grasp of what's going on and how you're handling the approach. But yeah, first time around it might be a little bit difficult. So yeah, I hope this helped, and I'll see you in the next one.